Hi everyone. Good afternoon, uh, good morning, good evening, depending on where you're joining from. And today we have another Quantum Pulse session by QETCI. We've been doing these monthly sessions to talk about the latest developments in quantum science and technology. The topics have been pretty varied. Sometimes we go very deep in technology. Sometimes we, look at the commercialization aspect and so on. Today we have a very, very interesting discussion lined up. It's given that today is Basant Panchami in India, which is when we celebrate the goddess of knowledge. We basically celebrate knowledge. Having a quantum pulse session, we did not plan it. We always have quantum pulse sessions on Friday, but having this session coincide with the day of knowledge is pretty cool, I think. And today we have a very knowledgeable, very well-known set of people here. I'll very quickly introduce them to you to have the discussion. Our topic today is to look at quantum in 2025 and beyond. So where are we today in terms of quantum? Both on the science and technology side, what do the ecosystems look like? And how do we see quantum evolving in the years forward? So please do some housekeeping information as and when you have questions. Please add those questions in the chat window and we will come back to you. There is a Q&A session towards the end. And so looking forward to this discussion. Thank you, Urbasi, Malak, Rasali for joining today. And we have, for the benefit of everyone, we have Professor Urbasi Sinha, Malak Trabelsi, and Rasali Venegas Gomez. All of them represent different geographies. And if you've been attending the Quantum Pulse sessions, you know that this is all the introduction that I will do because I want the panelists to introduce themselves the way they like and also give us a little bit of context on what they're doing. So over to you, Urbasi.
Thanks, Reena, and it's very nice to be in this Quantum Pulse session. So I'm Urvashi Sinha. I'm a senior professor at the Raman Research Institute in Bengaluru, India, and I also hold a Canada Excellence Research Chair at the University of Calgary in Canada. Of course, I can't be in two places at the same time. Currently, I am speaking from Bangalore. So happy Vasant Panchami and Saraswati Puja to everyone. Reena and I are wearing a yellow and orange to prove that today is Vasant Panchami. Having said that, I have also co-founded a startup, QSIN Technologies, around 1.5 years back, which is working on quantum solutions. I wear many hats. So I think one of them is to enable a lot of international linkages between India and other countries and so on. And so I also serve on the advisory board of the Open Quantum Institute in Geneva, which is mandated towards, equitable and geographically unbiased access to quantum. And likewise, I am in the IUPAP Commission 15 for AMO Physics. But then at a regional level, from the Indian perspective, have been playing an important role, I would say, in the evolution of the National Quantum Mission. I think we talk a little bit about that as we go along. Was one of the people who wrote the roadmap document for this, and now I'm heading a technology group on quantum repeater networks. So this is one of the 14 successful technology groups under NQM, and this is a consortium of many institutions with us playing the leading role in that. We also have regional strategies now. So I'm in the advisory board for the Karnataka Quantum Mission, which is the state or the province that Bangalore is in. And we have a Quantum City initiative here. So I think I can, so you get a feel for the kind of different things I do. And of course, scientifically, I work with photons, single and entangled photons, and their applications in quantum communications, computing, sensing, and foundations of quantum mechanics. So with that, I will hand it back to Reena.
Thank you, Professor Urbasi Sinha. Over to you, Rasali.
Hi, everyone. Thank you, Rina, for this invitation today. I'm really excited for this discussion. As I imagine that there are some students also in the audience, I would like to tell you a little bit about my career path as well. I'm originally an aerospace engineer. I work in industry for several years. Putting it very simple, I fell in love with quantum physics and decided to change my career from industry to academia. I moved from Germany to Scotland to do a PhD in quantum simulation. That was 2015. You know that the UK was the first country that launched a national quantum technologies program, like really top down from the government. And I was pretty involved in that in the UK. Thanks to being active in the UK ecosystem, but also beyond, in 2019, I got a fellowship from Optica, before the Optical Society, and I created my own company in 2019. Now, I was involved in the launch of the quantum flagship in Europe, what happened in the US, and I have been since actively involved globally in anything that has to do with quantum technologies. The company focused on that kind of preparation for the future, what companies and governments need to do to understand the value of quantum technologies. We really focus on quantum tech. We don't do anything else, but we try to bring quantum to everyone. And for that, we focus on education, consulting, community building, and we have done a lot of different things globally, also with a focus in Latin America, and I can tell you more about that. Thanks.
Thank you, Araceli. Over to you, Malak.
Thank you so much, Rina, for the invitation, and good afternoon from Dubai to everyone who's here. So I'm logging from UAE. I've been based here and work internationally. Also, I am having like not career change when it comes to quantum, but I've done different paths, and I landed in quantum, but I'm still where I come from the space industry. As you see, I have a nice background in space. So my background is law and economics academically, and I specialize in international space law, tech law, and worked a lot on space insurance contracts. So it's the from the private law perspective, so it's not public law, and that got me into working on different ventures and on different technologies when it comes to space and export control, national security, and then that was the not transition but expansion of scope of what I do is related to the due diligence that it has dual use of technology, security and defense, national security law, and how to be compliant with it. Of course, international contracts and joint ventures, investment contracts, and so forth. And in 2016, I was watching what happened in China with the first satellite that was deployed, the QKD-based satellite, and that got me very curious in order to understand. And I'm very, very curious person, and curiosity leads me to learning, and of course try to understand the implication of this kind of technology on the space industry from economic point of view, and then it expanded to the national security perspective and the dual use, and what I do every day with the clients and government entities that I advise. So the most important part was, okay, I can do something because it's a new technology, and I was more interested in quantum than AI, but AI is a part of it. We do a lot of contracts that is related to data privacy and data exchange and so forth. And that got me into launching the first company, which was Vernwell in 2020. Vernwell it was Vernwell Space and Tech. Then it changed to Vernwell Management Consultancy with a focus on different technology and space. And it was very, very attractive to me in order to understand also how I can build the economy and not the ecosystem at that point, is how I can contribute to this kind of technology. So we had different national, international initiatives in partnership with the governments, and that led me to what I do today. And if you go to LinkedIn, you will see what I do. The flagship activity is the Quantum Adoption Program, awareness that it turned into educational activities. And now we are working on readiness and adoption in partnership with different governments in the region and internationally with different organizations.
Thank you very much. And as everyone can see, right? I mean, we are talking about people who are working globally in many contexts, right? Uh, all three of you are actually working in more than one geography, doing different things. And uh, I was remembering a conversation that I had when somebody was asking me, do we need to do more for women in quantum? And I think we may need to do more, but you know, today there is enough woman power on this panel to show that some of the leading work in quantum women are involved, and we have people from all spheres, like starting from research to ecosystem to education, skill building to understanding the law associated with it and so on, right? So I think on that note, I would now request, this is a question to all the panelists, and the question is, since we are in January 2026, a lot has happened in the last few years in quantum. Where do you see quantum at this point in time, both from a global perspective and then specifically whatever is happening in your regions?
So should I start or?
Yeah, go ahead.
Okay, yeah,
Yeah.
because you didn't quite. Yeah, so first of all, I have to correct a mistake. You know, in my introduction, I forgot to say I'm in the governing board of the Quantum Ecosystems Technology Council of India, which is organizing this Quantum Pulse session. So my bad. That is, of course, one of the things I'm very proud of. So, okay, so going on to the quantum at 2026. So, you know, one of the things that I find very exciting, you know, I think this is a global thing, but also regional, is that, you know, we are currently, we have moved from it being something very niche and, you know, something like a NISC, small demo with errors, and we are talking more and more about a race for error correction and fault tolerance in quantum computing, for instance. So, you know, even let's say we're talking 25, 26. So even before that, it was mostly about increasing the number of physical qubits and so on. But now, if you look at the roadmap documents, even from India and otherwise, you will see that people are talking more and more of logical qubits and fault tolerance. And that is, of course, where we need to go, where a lot of work needs to be done. And so we are kind of already there in recognizing it and making, you know, sort of big treads towards that. Secondly, I mean, you know, there is also the important shift that I find in how the language is in terms of when we discuss quantum. So people like us, you know, we have been working in this domain for too long. I won't take the exact number of years because then that gives away the age. But then, you know, we have been more focused on research and so on and so forth, right? But then that is, of course, still remaining very important. And I hope we talk about that as we go forward. But governments, you know, they have moved from thinking, yeah, you know, quantum is nice to have, maybe somebody should do something, to it becoming a strategic industrial policy. I think, you know, this is something, again, it is across all global ecosystems that we are talking about critical infrastructure. OECD is another organization I'm sure we are aware of. They actually track 20 national quantum strategies. And so this means that we have moved from single things towards much larger policy level discussions in quantum. So basically going from large, some spectacular experiments to moving some of them towards maybe a little bit boring, but then very necessary engineering stuff to actually scale things up. And so we are in that juncture. So now where are we regionally was your next question. So I will speak a little bit more about India, a little bit less about Canada, because that is how I divide my time also. So the focus will be on India to begin with. So we talked about National Quantum Mission a little bit. I said that, you know, it's been happening, and we have been working on the draft and the launch and everything for a few years. From 2020 onwards, we've been doing this. It was launched in 23. But in 25, 26, we actually see it taking off, right? Really big time, with all the 4 hubs, as we know, you know, in computing, communication, sensing, metrology, and materials. They are all, you know, working well. They are coordinating calls for projects, startups, then also this Bachelor in Technology, Master in Technology programs for the education. These are also being coordinated at the hub level and beyond. So this is important. But then going to from a national to a regional perspective, we have the Amravati Quantum Valley, very close to where Rina is, of course, and then we also have the efforts in Andhra Pradesh, where, you know, regions, and then, of course, Quantum City and Karnataka Quantum Mission, and many others in Uttar Pradesh, Maharashtra, and so on, where regions are also taking specific interests and aligning with the national strategy. definitely not working in silos. There's a lot of connect with what we are thinking nationally and what we are thinking regionally. But in terms of technology, I think it's still a little bit early. We are still a little bit noisy, but there are important threads, we are happening in, let's say, photonic communication. I think quantum communication, we have had very important things happen in India, as well as quantum random number generators. So these are all things which are getting built. So, ultimately it would be a mix of both, chasing numbers at one level, qubits, kilometers, sensitivity, but also coming up with things which are fundamental so that we can build upon them a decade later, because otherwise there's nothing to do if everything is only about scaling numbers. So I think we are seeing this balance very well at a regional level in India. In Canada, almost something similar. We have the National Quantum Strategy, but there it is computing, communication, sensing. So not so much materials at the moment, the focus. But then, there maybe you have been following this. So they have something called the Quantum Champions Program. So they're picking up, startups and elevating them to the next level, handpicking, and they have this Champions Program, Challenge Program. NRC is doing this all the time. So what I want to see, 2026 go into is, more cooperation. So I, of course, have the privilege of being in both geographies. And so, we would want to have joint test beds, and we would like to complement each other in what we are doing best so that we can actually contribute more effectively towards the growth of the whole global quantum ecosystem. So that is my short take on where we are in 2026. Thanks, Reena.
I think Reena froze, but okay, I can move on. You mentioned the OECD. Like I've been part of the OECD Quantum Group since the beginning, and putting together that kind of what kind of general policies can we put on globally? How can we really think about a new country that wants to enter in quantum? What do they need to think about? And ethics and the ethical implications of quantum technologies. I remember in 2018, we were, I think, 5 people around the world that we were talking about that. And that became really a big topic. And I think nowadays is what you said, Vasita. I think the nations are really thinking about that, about regulations, about how can we work together. The geopolitical situation is a little bit difficult at the moment. So I think in terms of quantum technologies, we don't want to put any more export controls or anything. We want to work together. And I think that will be something that probably we will see more in this 2026. In terms of the of national strategies, we started in 2020 already with, I don't know, a map. You probably have seen it. It's our famous map with all the public investment. And it was really like every month there was a country announcing something. This has been obviously going a little bit slowing down, but I really feel that this year might happen that in some of the regions, maybe East Europe and Latin America, we see more coming up. I really hope so. Yeah, countries and governments are really seeing that this is coming, and they need to be part of the wave. That's really clear. In terms of the technology, to be honest, I think people are a little bit bored with quantum computing at the moment. It's like, this is going to take a little bit more time. Let's do something else. On quantum computing, what they are doing is really that hybridization. They are working with HPC. They are working with all things to say, we are still doing quantum, but we need to mix with all the things. And this is what we are seeing over and over again. And I think that is going to be just ramping up this year. And I agree, it has to be a focus on quantum communications, on quantum security, and in quantum sensing. And this is going to be really in my opinion, 2026 is just the other quantum technologies are also very important, and we need to use them. There are sometimes products that companies are not aware, and let's just develop that market as well. So I think that will be really the big thing, or I really hope that will be the big thing. So in terms of government's policies, the quantum security thing that now they are saying 2026 is the quantum security year. Yes, because we need to get ready. And since the quantum year is over from the International Year of Quantum, let's do something else. And if we just have that excuse to move together towards a quantum safe transition in all governments and companies, let's do it. I think those are really the big things happening. I just want to mention the Quantum Academy that is going to be set up in Europe, but I can tell you more later. intense when we talk a little bit more about education. There are things moving on, but let's be honest, things have been going a little bit slower since AI came up. So maybe we need to think about AI and quantum a little bit together to be able to push. This is just one thing I wanted to add.
So,
Over to
Rasili, a
you.
quick question. Thank you. A quick question on that. I actually, if you look at some of the announcements that the defense has been making globally and in different geographies, I would say that it seems to me that the impetus might actually, there might be more acceleration happening because of that.
Oh, that's for sure. There you can see that quantum sensing or PNT, depending on the government, is kind of the first priority, and then quantum communications, but not so much the post-quantum transition per se, but more the quantum more the post-quantum transition and not the QKD, more the software than the hardware. This is a discussion that I have been having with some governments. It depends who you talk to. But the defense, the dual thing that Malak was mentioning before, that is a crazy thing that started in the last quarter of last year. So now pretty much all over the world, if you want to do something in quantum and get money from governments, you just need to say that what you do has a dual use. That's the times we are living in.
That's interesting. And over to you, Malak. What are your thoughts?
I'll take a global lens and perspective, then I will go more into details with or near details what's happening in the region, especially in the UAE. So 2025 with the International Year of Quantum, it brought different many positive aspects to it. The most important part, which is the public awareness, which since 2020, I have been, pushing for the awareness and working on different initiatives on the national and international level. It was kind of not reaching to the public in general. Now the public most likely they are aware, and it's easier for us to speak to, for example, a regulator who is in the cybersecurity than before 2025. This is for sure, and it's evidence-based. So the quantum also stopped being one category, because most of the people, when we approach and we talk, even we listen to, they talk or they bring about the quantum computing, and they talk, when you talk about quantum technologies, they bring the quantum computing up to the front, and they actually forget unintentionally about the subset of the other technologies, which is, we talk about quantum computing, communication, sensing, and cryptography, and the demand from the government is separate now. So you have different regulators and different government entities around the world. They are working, for example, on procurement contracts and how to embed the requirement when they are working on procurement, and they are embedding, for example, the quantum cryptography conditions in it. And others, they are more from the military background. They are more into sensing, communication, and of course, computing. And actually, this is what I say all the time, working with the defense industry since some time, which is the space, because it's a dual use by nature. The most important part is to understand whatever it's in the public, whatever it's announced, actually it's not what's going in the military deployment. So they would bring it about later on when it's allowed to be in public. So also I have seen two other aspects that it is there. More and more we are talking about readiness. So readiness have moved its timelines. When we talk about the PQC, it was 2035, then it should be earlier right now, and the timeline is shrinking. And I see more and more governments, they are open, and they are actively working on the readiness and the transition timeline, and also actively working with different vendors, whether it is about the standardization or other aspects when it comes to PQC. Also readiness when it comes to quantum computing strategies. I remember when we started in 2020, it was very, very difficult to approach, for example, semi-governmental entity in order to work with them or advise on the readiness and what quantum, for example, computing can do, and you need to be ready. And it's not, of course, it's not efficient sufficient at that time, and it's going to be in the future, but you need to have that in your strategy for the emerging technology that can impact your activities. And the other one is the industrial scaling, and that
இதுங்க லிமிடெட் லயபிலிட்டி பார்ட்னர்ஷிப் மாதிரி அதுவும் ஒரு ஃபிக்ஸ்ட் அமௌண்ட் ஃபிக்ஸ்ட்
If
கேபிட்டல்
you're,
வந்து வச்சிருவாங்களா?
can you please be on
Fixed
mute?
capital ஒரே நிமிஷம் இருங்க.
If you are attending, please be on mute.
இப்ப சொல்லுங்க.
Amukta, can you please check and if needed,
it's done.
put
Okay.
the person out. Yeah. Sorry about that,
All right.
Malik. Please go ahead.
No
Yeah.
problem, no problem. So talking about the industrial scaling, it became more accurately deployable. So actually we partner with AD Ports Group, which is the leading entity. It's a gov entity in the UAE and one of the leading port operator plus digital transformation for the marine sector. We partner with them and we are working on different projects, and one of them was a KPI of the Quantum Innovation Summit, which was to work on the readiness of the maritime industry as they are a leader. And we launched the Quantum Maritime Conference and the different challenges, calling different companies in order to propose the solution. And then we're still working on, and it's unbelievably well perceived by the different other actors from the industry. That one of the readiness initiatives that we are working on. Also, you see that investments have been heavily poured, and also a new way of looking at different companies from the quantum full stack companies who are acquiring different startups in order to move forward and be a big force. There is something also it's happening this year, which is SPAC. It's the SPAC. It's a special purpose vehicle that I've seen it happening a lot in the space industry, and actually it was a big failure because of so many problems that it's related to governance. And now it hits the quantum, and actually I'm happy that it is there, but I'm worried that it will have the impact that is done with the space industry. Now with the UAE, Arceli, she said that probably in different area of the world is getting slow. Here it's like we are very busy with different entities, with what's happening, and busy also to capture the business intelligence of what it is out there. And what is out there, of course, is open source. They can share with the public, but there are so many other things that we are involved in that it is under confidentiality agreements that I cannot. But actually, financial industry is getting prepared. Cybersecurity authorities, they are working on that. Also, the maritime industry, also the other one. It's if you want to say the logistic, of course, I don't know if you want to put it under maritime, but logistic is multimodal. You can say aviation and others, they are
Sure.
also involved into it.
Sure. Thanks, Malak. I guess, there is a lot that has happened till now, and we seem to be gearing up in terms of awareness. We seem to be seeing a lot more progress happening, and, shift in focus because of the dual use and maybe re-acceleration. But what would you say has been the biggest impact of quantum till now, in your opinion? Malak, maybe you can start first.
The biggest impact of quantum until today to society,
Whatever you
or
think
to
is the biggest
businesses,
impact.
or
Yeah.
if I want to say to society, is the way how people used to perceive compute. It was difficult to explain to them, but today they are more and more aware, and they are convinced that quantum computing is going to, it's not only in the lab, it's going to perhaps happen that it will scale up, and they are getting ready. So I don't see, impact on industry when it comes to quantum computing, but I would see an impact when it comes to quantum sensing on the defense industry. So it's really, really important. And the impact on space industry also. So this is very important. The biggest impact I see on defense and security industries.
Okay, sure.
Rather
So
than that, no.
I'm going to ask you to, because I want to hear what other people's opinions are. And so your biggest impact, I understand, is more in your perspective, is in the way people perceive computing, and also on allied sectors like the space and the defense industries, right? And the fact that quantum has moved from the core to the allied sectors and is creating impact there as well. So that's excellent. And Araceli, what are your thoughts?
I was really thinking a lot, because if the question is what is the major impact of quantum, I can say, well, it's the first generation of quantum tech. That would be my first answer. But we are focusing on the second generation, right? If I think about the second generation, then my thoughts are really going to the future. So where we think that the impact is going to be.
No,
Now,
but what is the impact till now?
Yeah, until
What
now,
would
I
you
think that when people have tried to do optimization problems to see an advantage, and they have already made revenue and profit out of it, that's where really the impact has been done. There has been a lot of proof of concept on different use cases for quantum computing in different business sectors. Is it already something demonstrated to say it's a huge impact, or we are expecting that the impact is going to come? If it's a second, I would say then let's wait. In terms of sensing, there are really amazing products out there. I think the impact has not yet arrived, because a lot of people don't know that these devices exist, to be honest, like in the mining, oil and gas, etc. So yeah, I think in the Middle East, this might be massively disruptive. And in terms of communication, I think that people don't see the impact so far. We know the advantage, we know the value, we know that it's going to be amazing, but the impact so far, maybe little steps, maybe a little bit conservative here.
Okay, sure. Urvashi, what do you think?
Well, I think Malak and Araceli covered a lot of the, technological impact that we are seeing right now. But I think if I were to just step back a little bit, I would say again, because I come from the very academic background, I would say that, it has changed the way in which, we think about information, about trust, and about the role of physics in society. Because you see, we have grown up studying high school physics, then bachelor's, master's, whatever. So it's not a textbook thing anymore. I mean, the way quantum has revolutionized things, whether it is in security and computing, sensing, all of them were discussed by my colleagues here. But then the most important impact is that it has taken a very abstract theory. I mean, if you just look at the textbooks, they still remain the bracket formalism. But then it has turned it into something where, we are building trustworthy, ethically grounded, responsible societies. And we are talking about responsible usage of quantum. So it is not just an abstract concept anymore. I mean, so this is something which is becoming more and more a part of our lives. Yes, I agree with Araceli that, we need to make it a little bit more a part of our lives from the communication perspective, because I think the awareness still needs to increase there. People are not aware of all the great sensors that exist. Computing, I think it's still limited to the simulation ability and not so much the large computers, which we are all hoping would happen. But that is not the main thing here. The main thing is the slow but very sure shift over the last 100 years. Of the existence of this subject from being something, which has been a very fundamental thing. And this fundamental now grounds a lot of the technologies, whether it's first quantum. I also agree with that. The first quantum revolution is what we are today. And we're talking to you through one of them, the computer, the classical computer. But then the whole thought process, the ethos has changed. That is the big impact. And that is what we'll take forward for the next 100 years. It is not necessarily about one device or a second device. It's this whole evolution of a thought process of a society, which I think is the biggest impact that we see in quantum. Not so much AI, I would say. Because you see, if you think about it, AI is already, something people say, oh, it's artificial intelligence. So somewhere in our things, we think quantum is this deep physics textbook thing, whereas AI is much more recent. So, I mean, although it is also very revolutionary, but quantum, the shift, I think, is more impactful from that textbook to society.
So that's a different conversation. We are all very focused on quantum. So I'm
Oh,
sure
yeah.
that there are people who are AI experts will come and say,
Well,
get us
yeah.
into the conversation before you make that statement,
No,
kind
no,
of
we
thing.
are. I think we
But
are. I think Araceli already made this point very well that at some point we are looking at a convergence of these two technologies, right? Yeah.
right. So what do you think, Urvasi, is the most exciting things coming up in quantum from a science and research perspective?
Yeah, so now I finally get to answer science and research. Yes, this is, of course, what I mean, so I think, basically, we have already been saying this in different languages that the fundamental science is leading to the applications, and we are seeing more and more of that. And so if I want to take some very specific example, something that all of us may, even the audience, all of us, of course, know, but then the people who are listening to us are different age groups. So you hear a lot about Bell inequalities. You hear that the Nobel Prize in Physics was given in 2022 for the loophole-free violation of the Bell inequality. So these are about things, entanglement and spooky action at a distance, blah, blah, blah. But now this is forming the basis for secure communication, right? So whether it is entanglement-based quantum key distribution, teleportation, quantum memories, quantum repeater networks, which is actually much more at a nascent level than many of the other things we have discussed. That's why we have not yet talked about it, because it's still at a very R&D level. We don't really have that fantastic quantum memory which is going to link India and Europe and Dubai. We don't have that yet because we still are struggling with finding a good coherence time. And so this is where the research is. There's a lot of research being done on improving, this from a physics point of view, getting a quantum memory which actually stores for a reasonable time, also doesn't have too many other requirements for it to function. Similarly, quantum computing, if you think about it, while there is a lot of work going on in increasing numbers, numbers game is always there. And in quantum, we see it a bit too much. Somebody says 50 meters, somebody says 51, and they become press releases of their own. So that is the hype, which of course is also very much there currently. We didn't touch upon it so far, but Reena, you can trust me to bring it up for the first time in the conversation. I think, so this is something which is we don't need. So computing, we are looking at new platforms, but we are also looking at improving things in the existing platforms. Error correction is a fantastic example there, where we are trying to really come up with a good way of building that fault-tolerant quantum computer in the future. And then, of course, logical qubits and so on. So essentially, we are, in a nutshell, turning things which only seemed a little bit vague to people, like non-locality, entanglement, Bell inequality, Leggett-Garg inequality, quantum measurement. We say that when you measure something, it collapses. That actually is the reason why QKD is secure from a Heisenberg's uncertainty principle perspective and so on. So what I'm saying is that, in the beginning, because we are just out of that 100-year, but we're still in that hangover period of the 100 years of quantum mechanics. So I would say that in the beginning, the focus was more about the fundamental discoveries. Now they go hand in hand. We are having fundamental discoveries, but the yesterday's fundamental discoveries are becoming today's technology, specifically in computing, communications, and sensing. But materials should not be forgotten. Because I think one of the things which we have to understand is that there's so much expertise globally in material science and condensed matter physics. Now that is being leveraged towards building new materials for the compute or better detectors for my photons, because
Sure.
so this is where I think it's a great time to be learning about quantum and practicing it.
So
I'm
you're
getting
excited
philosophical.
about what's coming up on the field in general, right? But if
Oh,
I were
yeah.
to ask you, what is the most exciting thing for you, right?
For me, for my own work. Oh, yeah.
Yes, yes.
For my own work, the most exciting thing is, I touched upon Bell inequalities, but then, again, keeping the audience in mind and not just the panelists. So Bell inequalities are about two particles which are, or more, separated in space, right? So you have non-locality and realism and so on. But then you have this time equivalent of the Bell inequality, which is called the Leggett-Garg inequality. It was, discovered by Sir Anthony Leggett, who's also a Nobel Prize-winning physicist, and Anupam Garg. And so this is the time equivalent. So a single particle moves forward in time you can define similar correlations as the bell, but this is the temporal counterpart. In 1980s, it was discovered. And over the last several decades, people have tried to come up with experiments to close these loopholes. I already talked about loophole-free violation and the Nobel 2022 for the bell. So what we have been able to do, and we are very, very privileged to have done this experiment, we have done the first loophole-free violation of the Leggett-Garg inequalities in our lab in India, which is actually, I would say, a culmination of a community effort towards closing loopholes for at least 3.5 decades. So with this infrastructure, now we have been able to apply this for the first time to generate what are called semi-device independent random numbers. So random number generators, you hear a lot, randomly even. Everybody claims a random number generator. If you don't, you're not a quantum physicist. That is how I would say. But then, these are all still hardware-specific, device-dependent scenarios. We want to go towards a scenario where we don't worry about whether the device is compromised or aging. Because you see, we cannot prevent aging. We are all aging, Malak the least, surely. But then having said that, we are all aging. So this is something which should not affect my security. So we come up with something where we are device independent. And this is, if we get the right impetus, we would be the first company also. Now we have now translated this to the product level as well. So we have done the, first experiment, then we have done the random number generator in the lab. We've done it on an IBM quantum device to show that it can work on a noisy machine as well. Let's face it, those machines are not great. So we have been able to use them for this, and now we are building the, the portable product which we want to, sort of commercialize. So this would be the one example I would pick where I think, we have lived what I just tried to describe, fundamental physics to an application to a product which has been completely bottom up over the last 10 years in our lab.
Wonderful, thank you. Malak, over to you, since Urvashi very slyly included a compliment for you.
So much, it's so nice of you. Well, thank you. Actually, what excites me the most, of course, coming from the governance, perspective, and what I do within my job, and it's closest to my heart. Actually, what I see is the intersection of infrastructure, intelligence, and execution. Where the quantum technology are moving from experimentation into systems that shape real-world operations, and also the what I love the most is when I was talking about quantum and adjacent technologies and other immersion sectors. It was well perceived by the government. And why? Because of sovereignty. Now we are talking about sovereignty, and that excites me because at the end of the day, it's one of the most important parts when it comes to national security for a country, is to be sovereign within its critical infrastructure, the access of foreign companies into these kind of critical domains. And trust is very, very important. And of course, when it comes to sovereignty, we talk also about resilience and supply chain resilience and all these kind of words that we did not have the quantum as part of it, rather than it was taken over by AI. Today, European Union is talking about sovereign technologies, and quantum is one of them. If we talk about NATO countries, also they are in the NATO level, they are talking about sovereignty, and different nations are doing the same, and they are kind of working on allies and bilateral partners under bilateral agreements in order to join forces to do that under the umbrella of sovereignty, which is very, very important, and also readiness. So this year, I don't believe that it's my point of view, my humble point of view, saying that it's the international year of cybersecurity or security or whatever. Readiness. I think it's international year of quantum readiness, because it's not only about security. We are getting ready in all aspects of the quantum technology, and we don't want to bring one before the other. I think we want to do it all in all, because all of them are important. And quantum computing is one of the most important part for sovereignty and for national security for each country.
Thanks, Malak. And what do you think? So I see you being more excited from a governance perspective. Some of the topics which usually come in very late in the technology journey are actually happening very early on in quantum, in terms of the kind of social impact, the kind of impact that it is the conversations that are happening on the security side, and also in terms of ethical and responsible quantum and stuff like that. So the governance aspects are very exciting, like you said. Personally, what are you looking forward to? As you know, what is your main project as you go forward, and what are you excited about on that front?
Is it for Arceli or for me?
For you, Malak.
Oh, okay. Because Arceli, she's in ELSA too, so she's involved. Actually, what is when it comes to the different projects right now, when it comes to governance, you have the public sector or under the public law and whatever is related to regulations. So that's very important, and it's important to embed the ethical aspect of the technology. Plus, you have very important parts under the national security. It's the standardization. It's also the regulation when it comes to assessment and to whether it's the entity is sovereign or not sovereign, which belongs to the country or is coming from outside. There are different aspects to it and how you see that. So it's important, and which we are happy to support different entities, whether they are from the government side or from the private side. And the other part is the embedding governance within the contracts, and that's what I love the most. So and this I worked on for years when it comes to the space industry, and we need to be aware and informed about any new governance model or any new soft law, which is very, very important to embed it in the contract and to keep it as one of the rules and under a clause, so like that is binding for the parties of the contract, and that of course mitigate risks. That it's important for the legitimate interest of the party to know what it is there. So mentioning the regulation and also mentioning the ethical aspect, whether it's in the form of soft law or in the form of best practices. And that's what is very, very close to heart for me.
Okay, thanks, Malak. Araceli, now over to you. What are your thoughts on the, what is the exciting things coming in on the industry and the ecosystem side?
I was thinking about what Malak said about readiness. It was 3 or 4 years ago now that we published our paper on quantum readiness, where we were telling governments, industry, like the different stakeholders in the ecosystem, what we think that could be that readiness path. And that's how we also created these quantum technological readiness levels. And I hope that people use it. But yeah, I agree that we are getting ready slowly towards having a quantum technology market in place globally. I think in terms of the technology, what we are going to see, we are seeing is a lot of people, a lot of companies realize that maybe what they have, let's say, a single photon detector, what can I do with that? So now they are realizing that that is part of a really huge supply chain, and they can really work for different technologies. They are not going to say anymore, I'm going to create a quantum random number generator, just following the example from Urvashi, but maybe they're saying, I have this technology and can be used on this and that and that and that. And this is something that I'm really seeing a lot in a lot of companies. They realize that what they have is really, really interesting and can be applied for different things. So going a little bit out of this kind of focusing on one thing, like, I don't know, on algorithms. I'm doing quantum algorithms for finance. Now they are saying we have these fantastic algorithms that we can use for a lot of different things. And this is just going to grow. There is also a shift that quantum networks is going a little bit more out of the lab, and people are seeing this as a market. And this is becoming another pillar. We have shifted from having quantum computing, quantum communication, quantum sensing, and quantum simulation to now 3 pillars: quantum computing and simulation, quantum communication and security, and quantum sensing and imaging. And in quantum communication and security, for me, quantum networks is part of it. This is how we see globally. And quantum materials, I agree with Urvashi, this is part of the quantum computing and simulation, obviously, and this is going to be the revolution, but that's another topic. So in terms of these quantum networks, we see a lot of money from the government, a lot of companies for that. And why? Because this is going to be where the shift is going to happen. It's not going to be that you have specific device. It's going to be that we are going to be all connected using quantum sensors, quantum communication, secure quantum communication devices, and quantum computers. And in terms of that, from governments, from companies, that is the big shift. In quantum computing, as I said, I think it's going to be we are doing hybridization with HPC and classical algorithms. Everything is going to be not just pure quantum, but what else can I do? And we are going to see more people putting AI on whatever they do. That's for sure. Exciting for me is in terms of education, as I said, in Europe, we are launching this quantum academy. Before it was kind of you have the universities, then you have some people doing fantastic outreach. Then we were focusing on quantum education for industry. Now everything is going to be under one roof and working all together in Europe. And that means that hopefully we can create really a global quantum education infrastructure where, depending on who is the audience, that we can really build that career path and that readiness path for them. VET, vocational training, is something that not much has been done anywhere, to be honest. And I think the shift is going to be there. And I'm really, I'm looking forward to see what money will bring in to be able to focus on vocational training as well. In terms of community building, I really think that hopefully we can have Quantum Latino back this year. And it's because, again, Latin America has said we want to also do something in terms of quantum. But you have seen they are launching their quantum strategies. The case of Chile in the last weeks, but it's not just launching a quantum strategy. There has to be funding backing up that strategy. One thing is to say I want to do this, and the other thing is I'm going to put money to do it. And this is the shift that I really hope that we see this year. That is in a nutshell from the technical view, from the companies, and also from education.
Wonderful. So, and I think this is the education piece that you just talked about in terms of what's going to happen in Latin America. Is that your upcoming project which you're excited about?
Yeah, the Quantum Latino, the Quantum Academy and VET that I mentioned in Europe. And I just hope that more and more companies want to start that journey, that readiness journey when they want to get educated. I really hope that just grows. In terms of quantum security, that's our focus this year, is to be able to educate companies on what is all this about the post-quantum transition, the quantum safe transition, post-quantum crypto, the quantum communications network, what they have to do about it. So really that kind of, I take your hand in this journey and I tell you what to do, because they are like, this quantum computer is going to come and what should I do? What are the steps? And we want to work with them in that. And that is really exciting. And also to do it for governments. I see some people, what you see in Africa, I know that no one from us is based in Africa, but just to tell you that they are also doing a lot of stuff right now in Africa. They have a global initiative, and there are a lot of countries putting resources to build that ecosystem in the respective regions. So yeah, it's really global, and that is really amazing just to see that we are working together. So let's see what else can happen.
Thanks, Araceli. And I'm just curious. I heard, a very holistic discussion around both research, governance, what's happening in different ecosystems, and the industry overall. And everybody talked about literally like computing, communication, sensing, materials, quantum security. Now, out of these, if I were to force you to name one as the most happening place, or most happening area for 2026 and 2027 over just the next 2 years, this year and the next year, what would you say?
I start, I think it's
Yeah.
everything that has to do with communications and security. I think that will be the big shift.
Okay. Palak?
For me, I would say quantum computing in terms of investments and the momentum.
Okay. Urvasi?
Yeah, it's not good to go third on this one. I mean, I'm biased towards communications, but I mean, since we are just three panelists, we cannot deny that sensing has a very near-term impact. And so if you're talking 26, 27, along with communications, we will also have to remember all those very nice things which are coming out in sensing, which already are reaching a very high level of maturity, which we think will only grow. And communications, of course, I would be biased towards. So yeah.
Is it a bet?
No, I won't bet since I'll win.
A lot of confidence in everyone about what they are standing for.
Well, I had to switch, you see, because I was going to say communications, and then of course Araceli said it. So I mean, I just cannot, because we cannot be biased in this discussion. So I think both of them. I mean, it's difficult to choose your favorite child. So
No, I actually sort of thought that in case you did not say sensing, I would have stepped
oh,
in
there you
with
go.
my
Okay,
opinion. Because
so
I do believe that sensing is happening. Just yesterday, I was, giving a visiting lecture somewhere, and the conversation was on sensing. And one of the things that came up was the TRL levels for some of the work that different companies are doing in sensing. And that's pretty surprisingly high, right, compared to what we would have said 2 years earlier, right? Of course, some of them are still in prototype stage, but many of them have moved to trial stage and
Right.
actually done multiple trials and stuff like that. So I think that's pretty exciting. I would say that a lot will happen in sensing. And of course, you can't rule out communications, and actually, you can't rule out anything. If you are going to develop repeaters, I feel you will be developing technology for quantum memories, which will actually help computing as well. And so
That's
there's
right.
a lot of interdependency in terms of how momentum is going to build up. I feel, as you all rightly said, that there will be a lot more momentum as we move forward. And with that, I know this discussion can go on for a very long time. And I want to take some time to ask each one of you if you want to talk about something specifically that we have missed out in our conversations before we go to the questions. So we have another 5 minutes for you to speak about anything that you think you have missed out. I think if you are interested in talking about it, I would, what are your viewpoints on the geopolitical aspects and around quantum computing, quantum overall?
I would go and following up the question for which technology you think it will be most. I don't know exactly the accuracy of your question, but maybe we look at it from different perspective. So we would see it from an adoption, which technology will be mostly looked at for an adoption level. And quantum sensing with the TRL, we see Q control, they have very, very important technology, which is already showed proof of its viability and with the military. And again, what is happening with the military, we see only what they want us to see. So in that case, also quantum sensing has a major role in the resilience of the security industry when it comes to GPS denial and others. Still, there's a problem with the issue of some of the hardware and how to embed it. Also, when we talk about the maritime industry, there is a problem and could have a resistance with the societies and whoever that are working with the standardization and how to embed that, because it's highly regulated. And it's the same thing for the aviation. So if we want to say it adoption on a mass level, it will not. It will be from the military sector, and it will be really for trial basis. But if we want want to look at it from investments, I think investments, it goes more likely into quantum computing, again, if I want to say it, and that is the bringing the appetite of the VCs and others. So now we are moving away from the reliance on the government investments or funding into the VCs who are looking at the lucrative ROI that could happen in the near future, and that we see IonQ and with a very deep pocket with the acquisition and others looking for full stack quantum technologies around computing, internet, and whatever communication is involved, and so forth. So yeah, that's what I say. There is a problem with the communication side, which is what I see is the investments and the resistance of some government entities into putting the money in that, because it is heavy in investments, and probably they could see it as secondary funding opportunities to the cryptography first for resistance or for resilience. So that's the take, and I will stop there.
That's a wonderful perspective I think that's a good snapshot from an investment preference perspective, and definitely that is going to impact the way the technologies evolve, and thank you for that. And
I can
any other
take the
thoughts?
geopolitical thing, because I
Yes.
think that you just raised that point, and I think that is an important thing to comment on in this discussion. So see, there is always, I think, a difference between what is considered science and what is technology. And I think people who are in this business know the difference, right? Like, so when we are working as scientists, we love collaborating with other scientists, and we don't worry about where the scientist is based, and so if we have some sort of complementary expertise, we like to discuss and create something which may be otherwise difficult to create. And that is how science has progressed, through collaboration, through discussion, and through critical, through criticizing each other, and as a result improving things as we go along. So this mode is a very science specific mode, and quantum is not quantum is also in that genre, right? It's also very fundamental science after all. But then when we talk about something which has gone from a purely scientific pursuit to something which is becoming technology which is used, let's say, by strategic sectors. So even if you are creating a technology that is okay, then again you have a patent or whatever, that's fine. But then if now it is adopted by the strategic sectors, as Malak mentioned, the defense being one of the prime candidates for all these technologies. So then, I would say that in order to ensure that we do not suffer from, I would say, biases which come because of lack of knowledge about quantum. So I keep telling, if I do a BB84 protocol and Malak does a BB84 protocol, and we both know we are doing BB84 protocol, that doesn't mean I'll be able to hack into a system more easily, because it's protected by laws of physics in both locations. And so this is something I keep saying whenever I have an opportunity, but this is not common knowledge. And so in some sense, there is a misconception that, if I am doing something and if somebody gets to know, then I'm giving away a secret. That is not necessarily true at the scientific level. But when it has become something which has been adopted, then I do believe that the agencies in all countries are clever enough to ensure that they are keeping that adoption at a strategic level. And so people like us who are scientists, who are working bottom up, don't really get involved in that. So when then they take it, then they actually use it, then we are not necessarily helping them use it or whatever. So that it has been transferred. So there is science is collaborative, whereas technology is very personal. So all countries need to become technologically they need technological sovereignty in quantum. And this is where I feel the geopolitical, we don't want a geopolitical divide. Now if you think about it, there are only a handful of countries which are really, which really have the ability to make many more things than, let's say, the rest of the world. And if you think about quantum computing, as Malak very rightly said, that the investments are very strong there and the VCs are excited and so on. Again, that excitement needs to be shared across more countries. We have many more countries than are doing quantum computing. So if we are cognizant of this, then we will be able to have developments happen globally up to a certain level. And then, of course, technology also needs to be something which we can then export and import. Because, if I have the resources to build it in a certain country, I should be able to sell it to some other country to help protect their interests, because ultimately, as I said, laws of physics are not going to change from country to country. And one more discussion which keeps coming up, because unfortunately some of us are veteran panelists, right? I mean, we have done more panels than many other things in recent times, I would say, at least goes for me. I would say, the very important thing is the discussion about technology development in the global south. Now, there is this global north and global south, and this is very important because, people who come in, they say, this is what we need to do to help the global south mature and so on. And I feel, as a very proud member of that community, we don't need a lot of, hand-holding to know what is important for us. The problems that we face are fundamentally different from problems in a different geography. So, if there is a power outage, I know what it means. I have power cuts in Bangalore and I have UPS system to protect my lasers. But then in some other country, maybe power outages are very rare. So I need to solve my local problems using advanced technologies, including quantum. And so as a result of which, we need to enable, and we are poor people, but then I'm sure, we're all saying the same thing again and again, that, we need to ensure that science is not curbed. When it reaches a technology level, then of course, I'm sure there are people who are not in this call, who are going to take the call on how to use it so that we remain freer. Otherwise, we are going to be intellectually stifled if we do quantum science, and that is not what we want to be.
Sure.
That was a very long response.
No, but fair point. I think there is a lot of confusion. I think policymakers necessarily do not understand the technology well enough. And one of the things that I have been talking about is that we need to educate policymakers around the world. There is a problem with the hype as well, because when there is a lot of hype, and then what I say is that, when there are certain technologies which seem like, oh, this is a great thing, right? Actually, it's not a great thing. Everybody will reach that state very soon. Maybe this is not the thing you want to curb. You want to collaborate on this, but really curb something which you feel is really unique, right? Because, and then there are things which are going to be critical for the supply chain overall, right? And there is benefit in actually letting those things, for example, if somebody says, Erasli was talking about laser systems, right? And you're saying that, maybe if you go to a geography where they've just started the quantum work, then that would be very unique. But then is it really unique? Everybody can create those, if you put in the right effort. The science is well known, the technology engineers are equally capable everywhere else. So why does one need to restrict items which actually has no meaning? I think it only happens because the people who take those decisions do not understand the science very well. And hence the blanket approach is to curb a lot of things than they should be done. And I know I've spoken a little bit more than I intended to. I'm handing it over to you, Araceli, for your viewpoint on the geopolitical aspect.
No, this is a very interesting discussion. Obviously, I love your thoughts. I was thinking, what happened, because sometimes we get random people from all over the world asking, I want to get into quantum, what should I do? And a question that I got over and over is, should I buy a quantum computer? My answer is always, no. Why should you buy a quantum computer right now? Like, if that is really the first step that they want to do in quantum, it doesn't make any sense. But this is what people are doing. Not to miss the train. They just want to say, I have a quantum computer, even if that quantum computer is useless, be honest. So is that really the way we want to progress? That doesn't make any sense. We need to have policymakers that understand what they are doing so they can tell the government this is really the best way to do that. In my opinion, the government should be the first user, the first customer. We have amazing technology, then prove that there is an advantage. You should be the first customer for these, not trying to convince other people. And this so far has not happened, but I think we are going to see a trend towards that. The UK has said that they are going to do these quantum missions where the government is going to be the first user. We're still seeing how this is going to be happening. A lot of discussion there. In terms of the global south, I remember this was several years ago. There was some people in Latin America that they wanted to create a quantum computer where everyone could access. This is something that a lot of people are doing, this democratization of the access to a quantum computer. We have been using Qiskit for years, right? And at the end, it's kind of the similar thing. You have a quantum computer somewhere with a bunch of qubits that are not good, and you learn with that. Is that democratization that we want to do? Is that the way that you think that you are going to step into quantum? That's not. It has to be really thought of as a company, like the country should be your company. What is the strategy? What do we want to do? And what are we good at? I agree with your comment, Rina. If you have very good lasers, how can we ensure that our lasers are part of that supply chain? Not buying a quantum computer if you have absolutely no one that knows how to understand and use how to use that quantum computer. And this is something that I think governments are probably learning how to do. And the other thing, obviously, is that now there is a discussion a lot on talent, movement of talent. Obviously, we were offering recruitment for years, and one thing is that obviously we have a lot of talent coming from India, but can they actually be placed elsewhere? Can they be hired? Not so easy, right? At the time that you say you need to go through the visa process, it's like no. Don't send me people from overseas, but not people in your region, right? But governments are putting measures in place to be able to attract that talent. Netherlands have, I think, if you work in quantum, you don't pay tax, or you pay very low tax in comparison with the rest of people in that country. The UK is going to learn something similar. There are these initiatives to be able to have the movement of talent, but then at the same time, we want to retain our talent because it's scarce. How do we ensure that we want the talent to be able to move, but at the same time, how to attract and retain it in your country? This is kind of an open comment that I wanted to share, because this is, I think every country, we all want to do the same, but we cannot. There's just not enough people. In terms of quantum security, discussing the other day, I think we can really have, we can count with our fingers how many people in the world can actually be experts in quantum cryptography. I think they are just a bunch of experts.
Yeah.
Is that enough to make the transition? Probably not.
Right. Fair enough. I think talent movement is an interesting point, because everybody says they want talent, but then the visa restrictions have become, and job opportunities are linked to the way visas are treated. So there's a lot of that, and I think there is people who are writing questions, and they're becoming very, very impatient. So we'll move over to the questions, and
Rina, sorry, it's okay if I put the link to our website for some of the open resources, free resources that we have.
Sure. Please do.
Yeah,
Go ahead
thank
and do
you.
that. Yeah. Yeah. So, Lakshmi, you have a question. Why are most I don't think I understood your question, and could you please speak? You can unmute yourself and speak and ask the question. Lakshmi Chaudhramani. Okay, and what type of open resources we have to do basic circuit simulations? Some free resources have been added by Erasili. Anybody else has questions? Can you please raise your hand? Wow, amazing. What do we expect common usage of quantum systems? When do we expect, so Ashish Chadha has a question. By when do we expect common usage of quantum systems, just like AI? When do you think? How many years? Anybody who wants to answer in the panel.
First of all, I would like to probably reframe the question. Actually, quantum systems, again, we need to make the difference between the different quantum technologies, first of all. And the second point is, are we going to treat are we thinking that quantum, for example, computing is going to be like AI? They are different. So they leverage each other. But I think quantum computing, it's based on economic study that have been conducted. It's more likely it will leverage AI when it comes to quantum compute, okay? And not everyone will have a quantum computer on their desk, whereby everyone is using AI today, whether it's ChatGPT or others, so AI application. I think I wanted to put this into perspective, and I would let Urbasi answer and Arceli, because Urbasi, I think from your perspective, you can break it down as educator in order to probably make this framed in a better way to be asked.
When is quantum going to be useful? I mean, so then, of course, like AI. So, I mean, I would go back to Araceli's. Already she has given a particularly part response to this question. Quantum is already being used in everything that you see around you. I mean, and whoever asked the question, forget the name, but the fact that we are speaking to you through Zoom on a computer, this computer works on transistor logic. So, I mean, so whether it is a laser eye surgery or a classical computer, there are already quantum physics based applications that you are using without thinking. So it has been much more used by us as human beings for much longer than AI. Right? Because of course AI is much more recent, but then you are probably thinking more about the applications like quantum computing, quantum sensing, quantum cryptography, which are what we call the second quantum revolution. So there, I would say that already we have quantum sensors being used. There are examples of gravimeters. So there is one sitting on Mount Etna, which is basically figuring out the volcanic activities and relaying that. So it is a real life example. It's a very nice picture that also exists of this little device, not very little, but a device. Likewise, if I were to say, there are already adoptions for quantum crypto as well as post-quantum cryptography in many systems, including, for instance, in Japan or China or Singapore. India is also thinking very, very strongly on this. They've already formed a committee, and we are already discussing about this adoption as we speak in the financial sector. And there are fintech festivals have dedicated sessions on quantum, which actually means that they are taking this very seriously. And so it is already there. So far as the quantum computer is concerned, yes, that is one of the things which is currently not as, let's say, if we talk TRL, it is a little lower TRL for obvious reasons, because there is more work to be done. In terms of getting them more robust and larger numbers. But then already what is available is being used for beautiful simulations. As Araceli mentioned, it's not just computing anymore, it's quantum computing and quantum simulation, and then sort of latching on to hybrid, latching on to the HPC platforms. Many interesting things are already being declared as we speak. So I do not know whether the question was meant in what was the sense of the question, but then it has been used for very long, quantum, and second quantum is also very current and very future. So that would be my short chronological response to this one.
So that question was from Ashish Chadha. I hope Ashish, that question has been answered.
No, partly, yes. I meant when public can really see the quantum hardware system, they just seen the images of a sub-cryogenic system or something hanging from the top, but nobody has seen it.
Because you see, you are actually confused. I mean, so that is something which we all have, this unfortunate confusion that quantum is computing. I mean, and in some sense, well, of course, that is where there is a lot of investment needed and happening. There is a lot more to quantum than computing. And then if you, if you just searched a little bit, you would find quantum sensors and quantum communication systems also pretty easily available these days, actually. You can buy things and use them. And in fact, if you are using a Samsung phone built in Korea, you may already have a QRNG, which is in, some of these phones actually have a random number generator inside those phones. That was being done by ID Quantique and so on. So I don't know whether you have that phone, but some sections of public are already using it, Ashish. So yeah, the unfortunate thing is we always equate quantum with the chandelier, the dilution refrigerator, and then the various cables, which is a very specific technology, very important, but not the only one, right?
All right, thank you.
You're most welcome.
Yeah. There's another question from Sanjay Karthik. How does quantum sensing reshape system level design rather than simply improving the performance of individual sensors? That's a good one, actually.
I'll give one example and then others will also unmute. I think, one thing is, for instance, the MRI machine, right? Like, so, we have the magnetic resonance imaging, and if you are unfortunate enough, you've been in one, but you must have at least seen one, right? And so these are huge machines and they're really daunting with this huge magnetic field requirement and the noise that is associated. You have to wear a headphone so that you don't suffer from the noise and you can't twitch and so on. So now there is all this, this is now becoming portable thanks to certain kinds of quantum sensors. Certain quantum sensors lend themselves towards being small scale as opposed to this large machine. And so these portable MRIs, I would say, is at a system level because, as they become more and more robust and popular, they will change how we are looking at medical imaging, especially three-dimensional imaging perspective. So this is definitely an example. Likewise, there are microscopes which are coming out, which also make imaging that much more, hands-on and portable. So I think we are getting towards more portable designs for many of these things, which are more system level than just one example of a device. I'll stop and others.
Yeah, I wanted to add because I remember that exact question from some company saying, but I have already a sensor that does the work. Why should I think about a quantum sensor? But there are quantum sensors that are looking at measuring things that we are not using classically. And I love the example of being able to measure the magnetic field inside the ground, to be able to do a map of what is underground. That is massively an advantage if we think about construction sector, oil and gas, looking at resources. And I really think that even looking for water, that so far companies are not really investing in their efforts on. But I think that would be the massive change, looking at measuring things that so far we were not able to measure, on top of what Urvashi has already mentioned.
Absolutely. So being able to measure the electromagnetic signature of a single cell, right? So now what can you do with it? What kind of applications, what kind of designs could you create, right? So I think it's all about system level design now, because you can do new things, right? Design new systems. I hope that answers your question, Sanjay. All right. Any other questions? Or we are actually in the last 5 minutes of our session, and so if one final question we can take, otherwise okay, since there are no further questions, I will use this time to thank my esteemed panelists and very knowledgeable panelists and representing woman power from across the globe for this wonderful interaction. And I found it very interesting, and I'm sure the audience has too. We usually collect feedback, so we'll also let you guys know. We've had a pretty good audience. Our numbers range between 30 to 60, so there are more people this time. And thank you very much for taking the time, and look forward to continued conversations with all of you. Thank you very much. Thank you to the audience.
Thanks a lot, Reena, as well, for conducting this.
Thank you, Reena.
Yeah, thank you.
All right. Thanks.
Thanks, Malak.
Have a
Thanks,
good day.
Araceli.
Yeah.
Thank you.
Bye.
Bye-bye. Take care. Bye.